Section 4.6, couple of a moment. Let's first define what a couple is. If you have two forces that are equal in magnitude but opposite in direction, then they're considered to be a couple. And it can be at any angle. They're still considered to be a couple. And it can also be 3D. So it can be 2D or 3D. So now, let's take a look at the effects of a couple. So suppose I have my eraser here. So if I have my eraser, I apply a force in this direction and another one in that direction. It would cause this eraser to rotate in a counterclockwise direction. So this counterclockwise direction is the direction of the moment caused by these two forces. So this moment vector, we now will call it a couple moment. Let's see how we can go about calculating the magnitude of that couple moment. Suppose I have a wheel that lies on an XY plane. So here's my wheel, and I apply a couple and I can calculate the moment that this force causes this wheel to rotate about point O, or the z-axis that's coming up towards you. So that would be, using a scalar analysis, it would be this perpendicular distance, or the moment arm, times the magnitude of that force. So the moment about the z-axis would be this perpendicular distance times the magnitude of that force. To determine whether this value is negative or positive, I have to use the right-hand rule. I direct my fingers in the direction of the moment arm, sweep my fingers in the direction of my force, and my thumb points into the sheet. That would mean that it's a negative moment, or that it rotates in a clockwise direction. I do the same calculation for this force. I note that this is my moment arm because it is perpendicular to the line of action of F. I'll call that R2. And again, to determine the moment, it would be moment about that same z-axis. It would be R2 times F. To determine whether it's positive or negative, I take my fingers, put it along the moment arm, sweep it in the direction of the force. My thumb goes into the sheet. That would mean it's a negative, or it's the moment vector is rotating clockwise. The total effects of these two forces in terms of its tendency to rotate the wheel can be given by the sum of these two, right? So the resultant moment would equal to negative R1 plus R2 times F. But we note that R1 plus R2 is actually this distance between this force and this force, so it would be negative D times F. What I've shown you here is a scalar approach to determining the couple moment. We can also draw this moment vector, or this couple moment, in a 3D fashion. So let's say I have my X, Y, Z axis here. The wheel lies in the XY plane, so it would look something like that. And the force was applied in that direction. The other force was in that direction. Those two make up the couple. This couple moment is in the negative direction, meaning it's pointing downwards into the negative z direction. So I would have this moment resultant. Okay, this is my couple moment, and it is going in the negative z direction. So if I'm looking at it, that's my eye, right? It would be going in that direction. Okay, the next concept I want to cover is called a free vector. Let's say I have this ruler here, and if I apply a couple moment, regardless of where I place this couple moment, the ruler rotates the same way, right? So it's right here. And what I'm actually doing is moving my couple moment from here to here. And that's what a free vector is. You can actually move it move the vector without any difference in the body's tendency to rotate. So let's prove this. You can find this proof on page 154 of Hibbler's 14th edition. So suppose we have some kind of body and it lies in three-dimensional space, and a couple is applied to it. So we'll say that's a force F, and this is a force of negative F. And we'll call this point A, and we'll call this point B. And we want to determine the moment of this force about some point O, as well as the moment of this force about some point O. So we use a concept that we learned previously, and that would be R cross F. So moment about a point due to a force, I need to define this position vector. Same thing for here, I need to define that position vector. That would give me the moment about point O is given by ROB cross this F plus ROA cross that F. These forces are equal in magnitude and direction, so I can actually rewrite this like that. Let's say the resultant of this, ROB minus ROA, is equal to a vector R. Okay, so R is equal to ROB minus ROA. But on the diagram, what that is it's this vector here. Right? That's our R vector. So if that's the case, then I can say that this equation can now be changed to R cross F. So what this shows is that the couple moment is actually a free vector. The reason is that the magnitude and the direction of this couple moment is only dependent upon this position vector R. It's not dependent upon this position vector ROA or ROB. That means I can take these couples and I can move it anywhere on the object. Okay, I can move it anywhere. It doesn't matter because the way that the couple moment is calculated is only dependent upon the position vector that separates the two. So let's do a problem. Here we have a pipe assembly subjected to a couple. We're given some dimensions where we know that this is 8-inch, that this angle right here is 30 degrees, and the length of the pipe that protrudes down into this lower quadrant below the XY plane is 6 inches in length. What we want to do is to be able to determine the couple moment acting on the pipe. So we want to know the moment, so solution. So we can solve this problem several different ways. Let's do the simplest, which would be the scalar approach. And that's defined by the following equation. The couple moment is equal to d, which is the perpendicular distance between the couple, times the force. So to determine this perpendicular distance, all we have to do is draw the line of action of F, and we can see that this would be the perpendicular distance between the couple. So we can find that length by using Pythagorean theorem. That would be cosine of 30 is adjacent over hypotenuse. So that would be 6 times cosine of 30 degrees. Therefore, the moment is 6 cos 30 times 25 pounds. And this would give us a value of 5.196 inches. So our couple moment is equal to 129.9 pound-inch. We can also solve this problem using a vector approach. So let me just fold this like this so I don't have to redraw the figure. So let's use a vector analysis. Okay, so to determine the couple moment, we can use a formula that says the couple moment is equal to R cross F. I'm going to take the moment of each of these forces about 0.0. So that would give me this position vector right here. Let's call this point B and call this point A. So we'll call this position vector OB, and we'll call this position vector right here R from O to A. And the computation goes like this. So I'll have R from O to A cross this force, which is a positive 25K, plus that would be R from O to B cross 25K, plus R from O to A, cross it with this negative 25 pound force in the K direction. We can determine this position vector ROB to be 6 times cosine of 30 in the X, 8 inches in the Y, and negative sine 30 times 6. Sine 30 degree times 6 in the K direction. So that would be 6 cos 30 I plus 8j minus 6 sine 30k and we'll cross that with 25k, and then we'll add R from O to A, which is simply 8 inches in the J direction. So that would be 8j, and then we'll cross it with that negative 25k. Moment of the couple about point O is equal to negative 200I minus 129.9 j plus 200I. Pound feet, that simplifies to negative 130 j pound inches. Sorry, I made these should be in inches. Okay. We learned. So there's also another way to do this problem. Instead of using ROB and ROA, I can just find the couple moment by using a vector that begins at this point and ends at that point, meaning that position vector lies somewhere along the line of action of this force and somewhere along the line of action of this force. So another method to compute the couple moment is to use vector analysis. We can use a formula that says the couple moment is equal to the position vector cross the force F. So this position vector has to start somewhere along the line of action of one of the couple force and end up at a point anywhere along the line of action of the other force F. So it has to start at a point along the line of action of F, and that's the end also at a point anywhere along the line of action of the other force. So let's go ahead and compute that. So the couple moment then would be position vector R from B to A. So R from B to A, cross that with my force vector F that's going downwards. So that would be positive 6 sine 30k. So positive 6 sine 30 in the k direction, and negative 6 cos 30 in the I direction. And we'll cross that with the force of negative 25 pounds. So that would give us pound inches. And if we carry out that math, we will get the following: minus 130 j pound inches. This negative sign means that if we were to look in this direction, we would see that the pipe would have a tendency to rotate in the clockwise direction, meaning the couple moment would be in the negative y direction.